This video takes you through some problem solving in coordinate geometry. Before we get into the problem solving and the tricky questions, I'm just going to remind you of what your toolkit is for this chapter. Your toolkit consists of first, circle geometry, all the theorems that give you a 90-degree angle. So there's the angle in a semicircle. There's the fact that the perpendicular bisector of a chord goes through the centre, and the fact that a tangent meets a radius at 90. You also got your basic equations. Vertical line, x equals something. Horizontal line, y equals something. Straight line, fill in this template. Don't fill in all of it. Leave the x and the y because you want an equation, but fill in the m, that's the gradient. And the x1, y1 is any point that it goes through. What else have you got? Equation of a circle, fill in this template. So r is the radius and a, b is the centre. So you've got your equations and you've also got three formulas. You want to know the gradient of a join between 2 points, x1, y1. Use this formula. You want to know the distance between 2 points. Just take the x coordinates, subtract them and square. Take the y coordinates, subtract them and square. Notice that because you're subtracting and squaring, it doesn't matter if you're sloppy about the order with these, whereas it massively matters about the order of those. y2 minus y1 over x2 minus x1, not the other way around. You can do it as y1 minus y2 over x1 minus x2, but you have to be consistent about what you regard as first and what you regard as second. Finally, midpoint. You have 2 points. You want to know what point is halfway between them. Take the mean of the numbers before the comma of the x coordinates, take the mean of the numbers after the comma, and that would be the midpoint. So you've got your circle geometry theorems, you've got your equations, you've got your formulas, you've got your general techniques. So the simultaneous equations will be massively important for this, and drawing a diagram. Okay, so let's have a look at some tricky questions. Okay, example 4 from the chapter. The line AB is a diameter of a circle where A is -1, 4 and B is 5, -2. So 5, 2. We are told that AB is the diameter of a circle. This is me completing the circle. That's me drawing a diagram. Find the equation of the line that is perpendicular to this joint and also goes through the centre of the circle. Well, it'll be a perpendicular bisector. It's going through the centre because the centre will obviously be halfway between the two endpoints of a diameter. So I'm going to fill in this template. Now, for x1, y1 I need a point that it goes through. It will go through the midpoint. So the midpoint is the mean of those. So that's 2. And the mean of those, which is 3. The gradient is of this joint is that minus that, 2, over that minus that, which is -6. So the gradient of this is 2 over -6, which is -1/3. So our gradient is 3. And that's the equation of our line. Of course you can tidy that, but that of course is technically correct. I'll just remind you of the strategy. For the point that I needed, I took a midpoint of these. That's this formula. And for the gradient I needed, I worked out the gradient of this using this formula. And then I switched from the gradient worked out using the formula to its negative reciprocal because I wanted the line that was perpendicular to it. Here's example number 5. So, we've got the centre of a circle, which is at negative 3, 5. There's some points P and Q which are on the circle. So 5, 4 and 1, 12. So that's P and that's Q. That's the centre of the circle. I haven't drawn this very well. Like that. It's P there. The line L is perpendicular to PQ and bisects it. Now we know that a perpendicular bisector of a chord goes through the centre, so I can continue that line through the centre. But that's just in terms of the accuracy of my diagram. It now says show that it passes through the centre. Well, let's find the equation of it. And then I'm going to substitute negative 3, 5 into that equation and hope that I get something true. Of course, I know that it goes through the centre by the circle geometry theorem. I guess this question is asking me to verify that algebraically. The midpoint is for the x's, the mean of the x values, which is 3. For the y's, it's the mean of the y values, which is 8. And for the m, it's the difference of the y values, which is 8, over the difference of the x values, which is negative 4. So the gradient of that is negative 2. Makes sense because it's sloping down from left to right, that's why it's negative. But our gradient is a half because we want what's perpendicular to it. In other words, we want the negative reciprocal. So that's the equation there. Now, the question is that true if I put a 5 where y is and a negative 3 where x is? So that's that question, example number 5. Okay, example number 6 is about a circle. And you've got y equals 3x minus 11. This is negative 11, so y equals 3x is a pretty steep gradient. 3 is pretty steep, so I'm going to draw that as y equals 3x minus 11. That's a perpendicular bisector of AB. This isn't the only place to put AB, but it certainly fits with the perpendicular bisector information. Other line, y equals negative x minus 1. It's a gradient of roughly negative 1, and that's a y-intercept of negative 1. This is perpendicular bisector as well, we're told. this time of CD. Now, perpendicular bisectors go through the centre, so this has to be the centre. It's the only way for them both to go through the centre. And we find the coordinates of the centre of the circle. Well, we just solve simultaneously, since they both go through the centre. So 3 subtractions, that minus that is blank, that minus that is 4x, that minus that is negative 10, so x equals 2.5, and therefore y equals negative 3.5. So the centre is that. Example 13 says that there's a line which is the diameter of a circle, and the line is AB, and 4,7 and negative 8,3. The points at either end of the diameter. Find the equation of the circle. Well, the equation of a circle is this. The centre of the circle, if this really is a diameter, must be what's halfway between. So the centre fills in A and B. For the centre, take the mean of those, that's negative 2. And the mean of those, which is 5. And for the radius, take half the distance between those. The distance between those is this minus this, all squared, plus this minus this, all squared. So the radius is half of that. Just simplifying this because it'll be easier to take half of it. So the radius is half of that, which is root 40. So therefore the radius squared is 40. And that is your answer. So that's the equation of the circle. Of course you can tidy that up. Example number 14, we're told that 4x minus 3y minus 40 equals 0 touches the circle with this equation at just one point, which means it must be a tangent. Show that the radius at P is perpendicular to the line. Draw a diagram for this. It's really easy to graph a circle. The radius is 10, the centre is 2,6. So it goes up to 16, down to negative 4. So that's your circle there. Got a radius of 10, as I say. And 4x minus 3y equals 4. Just graph that quickly. If y equals 0, then x equals 1. And if x equals 0, then y equals negative 1 1/3. This is so that's the line there. Oh, sorry, I made a mistake there. It's not minus 4, it's minus 40. So that goes way down here. And that's P, which is 10, 0. So this is a terrible diagram. Really terrible. I'll start this again. So 2 comma 6 would be here. So the graph goes up to 16. Really should use compasses for these. 0, 10 is there. Oh, sorry, 10, 0 is there. The line is 4x minus 3y minus 40 equals 10. The y-intercept of that is negative 13 1/3. I just got that by making x equals 0 there and then solving. So we have to show that the radius at P is perpendicular to the line. Okay, well, we know that's the case anyway from circle geometry. This question is asking us to verify it. So the gradient of these is that minus that over that minus that. So that's negative 3/4. Whereas the gradient of this, I'm going to make y by itself. Divide everything by negative 3. So the gradient of that is, so m1 times m2 equals negative 1, so therefore perpendicular.